Okay, some of my students were having trouble with some of the problems on their team talk activity. And before I get the kids to share what they got for their answers, I'm going to address some of the items that caused them to have some problems. The first one they mentioned to me was number 6. And that's this item right here. Number 6 says, complete the chart by writing an expression for the pattern. Now, it will be an algebraic expression because we're going to have variables in it. And I see some hands already. You have a question, child? Yes, it's recording. It's recording. Yes. I have a class full of children, and they're watching me make this video as I demonstrate how to find the pattern and write an algebraic expression that helps complete the charts. Now, that's the big deal. It's more important that we figure out an expression that will help us complete the chart, whether it be this one here or whether u would equal any values. For instance, here, this top part at the end, we have 1/4, 2/4, 3/4, and then we have u. That u could be any value at all. Our out part is right here. So anyhow, just to kind of go over a little bit of vocabulary, a pattern is established when it can be observed at least 3 times. At least 3 instances of the same thing occurring, that's going to be a pattern. And so we're going to figure out these algebraic expressions after figuring out the pattern and the structure of the data charts that we have. One of the things that I would ask my students to consider is, what do you do to 1/4 in order to get 1? What do you do to 1/4 to get 1? Okay, what do you think you do, Gracie?
You multiply it by 4.
You multiply it by 4. Well, let's just see if that's actually what you do. So let me get a little bit of scratch paper here, and we'll try that and see what happens. So I'm going to put my scratch paper over here. So if I have 1/4 and I times that by 4, let's see what I get. Well, let me turn this 4 into an improper fraction. And I already see right off the bat, I could cross cancel, but I'm just going to go ahead and multiply numerator by numerator, denominator by denominator, and then I'll simplify my product. 1 times 4 is 4, 4 times 1 is 4, so 4/4 would equal a whole, or 1 here, okay? Now, that's what you do to 1/4 to get 1, but what do you do to 2/4 to get 2? Let's see, what relationship do we see there? What do you think we're going to do? Laney.
You're going to multiply 2/4 by 4, and that will give you 2.
Well, let's try it out. Let's see, I've got 2/4 times 4. Once again, I'll have 4 over 1. And 4 times 2, 4 times 2, 2 times 4, is going to give us 8. 4 times 1 is 4. And then I can get 2 groups of 4 out of 8. So 8 divided by 4 is 2. So sure enough, by multiplying 2/4 by 4, we get 2. Now, if we can multiply 3/4 by 4 and get 3, then our pattern will be, you multiply the in data, and that will give you the out data. So let's go ahead and try 3/4. So 3 over 4 times 4, which will be 4 over 1, equals 3 times 4 is 12. 4 times 1 is 4. And then 4, I can get 3 groups of 4 out of 12. So 12 divided by 4 equals 3. So sure enough, it looks like our pattern holds. You multiply the in data by 4, and that gives you your out data. So we can say 4 times u is the algebraic expression that we will use. Now, we can write that a couple different ways. We could say, for instance, and I'm going to get in a little bit of scratch paper here, we could say 4 times u, like that, or there's another way. In this expression, we have 2 terms. We have a constant, we have a variable. We can combine those 2 terms and have just 1 term where we'll have a coefficient and a variable. Well, Burns, what do you think? 4u. So our algebraic expression for this problem could be 4u. Then any in given data point that we get, whether it's 4/4, or if it's 5/4, or if it's just a whole number like 50. You times it by 4, and it will give you the out data point. Y'all got that?
Yeah.
All right, let's move on to the next one we had trouble with. But I'm gonna go ahead and start a new video for our next problem that we had.